This week in CIST 2612, we'll look at Chapter 9, Digital Forensics Analysis and Validation. In this chapter, we're going to look at what data to analyze in digital forensic investigations. We'll look at the tools used to validate the data. We'll also look at common data hiding techniques. When you examining and analyzing digital evidence, that will depend on the nature of the investigation, the amount of evidence or data you need to process. Criminal investigations are going to be limited to finding data as defined in the search warrant. And civil investigations, they're often limited by the court orders for discovery as well. You may have a scope creep, which is when the investigation exceeds beyond the original description because of something that's been found in discovery or unexpected evidence increases the amount of work required. A couple of ways you may have this is that you have the unexpected evidence. An attorney may ask the investigators to examine other areas that allow them to recover more evidence. Now, some scope creep increases. Scope creep is going to increase the time and resources that are going to be needed for you to extract, to analyze, and to present the evidence. This is something that's becoming more common. The criminal investigations, they require more detailed examination of evidence just before the trial. It's also used to help the prosecutors fend off attacks by defense attorneys. A lot of times new evidence, though, isn't often revealed to prosecution. It becomes more important for prosecution teams to ensure that they have analyzed the evidence before the trial. To begin a case of creating an investigation plan, it's going to define the goal and scope of the investigation, materials needed, and tasks to perform. Now, the approach you take is going to depend largely on the type of case you're investigating, whether it is criminal, civil, or corporate. But these are some of the basic steps for all digital forensics investigations. You want to, for targeted devices, use recently wiped media that have been reformatted and inspected for viruses. Inventory the hardware on the suspect's computer. Note the condition of the seized computer. For static acquisitions, remove original drive and check the date and time values on the system CMOS. Also record how you acquired data from the suspect's drive. You want to process drive's contents methodically and logically. List all the folders and files of the image or drive. Examine the contents of all the data files in all folders. Recover file contents for all password protected files. Identify functions of every executable file that doesn't match hash values. Maintain control of all evidence and findings. Now, if you're doing an investigation, let's say that you're doing an investigation of an employee that's been suspected of industrial espionage. That's something that can require really the most work. You want to emphasize the importance to the company of ensuring that they have set up rules of use and limitations of privacy rights. You want to make sure that the investigators, as the investigator, you should maintain control of all evidence and findings. And make sure you document everything as you progress through an examination. Now, sometimes you may have to modify a plan. So even if your initial plan is sound, it's perfect, at that time, you may need to deviate from it and follow the evidence. So you want to know what the types of data to look for that helps you make the best use of your time. The key of this is to start with a plan, but remain flexible in the face of new evidence. So you may have to refine the investigation plan. It's important to determine what the case requires so that investigation is broad enough to encompass all evidence, yet not so wide-ranging that time and resources are wasted. But remember, you may have to adjust that. So be flexible when you're doing your investigations. Have a plan, but know that you may have to deviate from that plan. Now, autopsy, this can analyze data from several different sources, including image files from other vendors. You can use it to perform forensics analysis on the operating systems like Microsoft FAT, NTFS, Mac, iOS, Linux. Autopsy can handle many formats, including the raw expert witness, virtual machine image files. The utility has indexed versions of the NIST National Software Reference Library of MD5 hashes. And then there you can import the NSRL reference hashes into autopsy. So you don't have to when you do this, you do need to make sure that you download the latest version. All right, so the next few screens, we're going to look at the hash database options for autopsy. So when you collect hash values in autopsy, you create a hash database of known files of interest. If you want to know more about autopsy, you can visit sleuthkit.org/autopsy. So we see a screenshot here of the config and ingest modules window. Where in this case, you're doing a hash lookup. We'll see an example of a hash values located here. Now, the reason it's important to ensure the integrity of data so it can be presented as evidence in court. Most forensic tools offer hashing of images files. You want to make sure that you have your data the integrity of the data is preserved. This is going to be known as validating your data. It's one of the most critical aspects of the digital forensics. You can use tools such like advanced hexadecimal editors to ensure the data integrity. Now, digital forensic tools do have some limitations performing hashing. So maybe using an advanced hexadecimal editor will be necessary to ensure that data integrity. Now, these offer many features that are not available in digital forensics tools, such as hashing specific files or sectors. Now, getting hash values with full-featured hexadecimal editors can be faster and easier than with a digital forensics tools. And sometimes, as investigators, you're going to need the hash value of specific files or sectors to validate whether the data or the fragments, the sectors that will match the contents of a known file. So with that hash value in your hand, you can use a forensics tool And there you can search for suspicious files that may have had its name changed to where it looks like an innocent file. WinHex, it'll provide MD5 and SHA-1 hashing algorithms. So when we look at a file open with WinHex, we will see the data. This is the compute hash dialog box. And then we see the hash results. All right, so now the advantages of using hexadecimal editors is you do have advantages for recording hash values, so you can determine whether the data has been changed. Now, blockwise hashing, that's the process of hashing all sectors of a file and then comparing them with sectors of a suspect's disk drive, to determine whether there are any remnants of the original file that couldn't be recovered. So in there you build a data set of hashes of sectors from the original file. It's going to examine the suspect's drive and see whether any other sectors match that. If the identical hash value is found, you then confirm that a file that was stored on the suspect's drive. You can also use hash values to discriminate data. Now, access data is going to have its own hashing database known as the known file filter, as contains the hash values of known, legitimate, and suspicious files. That is going to be used to identify files for evidence or eliminate them from the investigation if they are legitimate files. So what this does, it compares the known file hash value with the files of your evidence drive to see whether they contain suspicious files. If they do, you can investigate them, and if they are legitimate files, you can exclude them from your investigation. The next section is talking about validating with digital forensic tools. So we're going to go back to the Access Data FTK Imager. So when you select the expert witness or SPART format, you will have other options. So you have additional options for hashing all the data that's available. The validation report lists the MD5 or SHA-1 hash values. So by choosing the Access Data FTK Imager, and when you select the Expert Witness 1 or Smart format, you do have these other values, the other options. Now, Autopsy is going to have a similar feature called EO1 Verifier. That's for verifying an expert witness image file. So we see an example here of the FTK Imager case information file. This is the MD5 hash value being recorded. All right, data hiding, that involves changing or manipulating a file to conceal the information. There are some common data hiding techniques. This includes hiding the entire partitions, changing file extensions, setting the file attributions to be hidden, bit shifting, also using encryption or setting up password protection. Now you can also hide files using the operating system. One of the first techniques to hide data would be changing the file extension. Now, let's say a suspect wanted to hide an Excel spreadsheet. So they could change this extension from the .xlsx to a .jpeg or .jpg. Now, what happens in this is that most advanced digital forensic tools, they'll check the file header. and they'll compare that file extension to verify that it's correct. If not, the tool will flag the file as a possible altered file. Now, another hidden technique in operating systems is selecting the hidden attribute in the file's property dialog box. One of the easiest ways to check this, you can have in your File Explorer, you go to View, you can choose to show or hide the hidden items. So if a file, the property is set to hidden, and I'm going to apply this, you'll see now that the Chapter 9 PowerPoint is no longer visible. If I click the hidden items, it's now there. Okay, so this is a very easy way to check to see if a file is hidden. Now, you also have digital forensic tools that will search for that as well and check for this. When we talk about hidden partitions, you can use, someone can use something like Windows disk partition utility diskpart to hide the partitions. So we can use the Windows diskpart remove letter command, and assigns the partitions letter and hides the view from File Explorer. To unhide this, you can use the diskpart assign letter command. They have other disk management tools such as im-magic, Linux, ease use, or ease partition master. Now, to detect whether this technique is in use, there you should be able to account for all of the disk space when examining the evidence drive. Now, most digital forensic tools or hexadecimal editors can access disk areas containing space that cannot be accounted for, so they can detect and view the hidden partitions. But if you see a chunk of space missing and you can account for it for what you can see, you can then check to see if you have a hidden partition. As you see on the screen, located here, we see that we have this section is hidden. So we see a capacity, when we see a large chunk is missing, we can just determine that something has been hidden in the partitions. This is a screenshot of viewing a hidden partition in autopsy. So we have our hidden partition using the digital forensic tools. Another data hiding technique, it's using the FAT file system, is placing incriminating evidence in free space or slack space on a disk partition clusters. And this may be using an old utility such as Norton Disk Edit. This is something that's no longer really commonly used. In this, a suspect then could mark the utility, could use the utility to mark good clusters as bad clusters. So the operating system will no longer have access to those. So the only way they can be accessed from the operating system is by changing them to good clusters with a disk editor. Disk Edit will run only MS-DOS. It can access only FAT formatted disk media as well. We also need to discuss bit shifting. Bit shifting is a process of shifting one or more digits in the binary number to the left or right to produce a different value. So it changes the data from a readable code to data that looks like binary executable code. This is something that is a low-level encryption. It makes the altered data unreadable to a secure file. The user needs to run an assembler program to scramble the bits. They need to run another program to restore the scrambled bits to its original order. WinHex and Hex Workshop include a feature for shifting bits. You can also use WinHex to check the MD5 hash value for the files. So we see an example of a bit shift text open in WinHex. See the modified data dialog box. So they've got the left shift by 1 bit. Now when the bits are shifted, you'll see that the code is no longer readable. Steganography comes from the Greek word of hidden writing. That's hiding data inside of an image. So we embed information in another file for the purpose of hiding that information from casual observers. So we hide this inside of another file. Now we hide this so that the intended recipient is the only one that knows the message is in there. Steganalysis is the term for detecting and analyzing steganography files. Digital watermarking. That was developed as a way to protect file ownership, so something's not usually visible when used for steganography. Is what the digital watermark is. Now there are many different types of freeware or shareware that's used to hide data. You can insert this information in a variety of files. One of the easiest ways is maybe put it into an HTML file. If you comment for example, if I'm sending a secret message, I may insert this into an HTML file and put it in the comment so it's not read. I can also encrypt a plain text file with PGP. I can insert the encrypted text into the steganography file. In that, cracking the message may be extremely difficult. There are some different steganalysis methods. You can use stego only, known cover attack, known message attack, a chosen stego attack, or chosen message attack. All right, so you can use programs such as PGP or BestCrypt to encrypt files. Now, key escrow. It's a technology that's designed to recover encrypted data if the user forgets their passphrase or if a user key is corrupted after a system failure. Key sizes of 128 bits to 4,096 bits make breaking them nearly impossible with current technology. So this is something that's really going to be the resources needed to crack encryption schemes. There's something that usually are beyond what's available to small or medium organization. Investigators should make an effort to pursue suspects to reveal the encryption password or passphrase. There are several password cracking tools available for handling password protected data or systems. Many are integrated into digital forensic tools such as OS Forensics. There are some other standalone tools like LastBit, John the Ripper, passphrase, and more. Possible letter, number, and character found on the keyboard. They use those. This method can require a lot of time and processing power. A dictionary attack. This uses common words found in a dictionary, and it's going to try them as passwords. And most of these are going to use a variety of different languages as well. Now, many programs like you build profiles of a suspect, helps you determine what his or her password is. Many password protected operating systems and applications restore their passwords in form of an MD5 or SHA hash values. The brute force attacks was going to require converting a dictionary password from plain text to a hash value. And this does require additional CPU cycle time. A rainbow table is a file that contains the hash value for every possible password that can be generated from a passwords, which alters the hash value, makes cracking the passwords more difficult. When you saw the password, you add a bit to the password before it's hashed. So in there, the rainbow table can't find the matching hash value to decipher the password. So in Chapter 9, we looked at examining and analyzing digital evidence and how it depends on the investigation, the nature of the investigation, the amount of data processed. We looked at some general procedures. We looked at some different advanced forensic tools for recovering passwords. We looked at ways to hide data, recover data. One thing to remember here is when you go into an investigation, have a plan, but be flexible. Realize that that plan may change as your investigation goes through its motions.